Ladies and gentlemen, welcome to the first installment of Distance Learning with Mr. Morales. This is guaranteed to be highly awkward, but extremely informative as we go through test corrections on your way to doing test retakes and getting a better grade in physics of the universe. What could be better? All right, so we're going to start with the first test that this year, Introduction to Energy. What I'm going to do is go over the questions. This is version 1 of the test. When you do a retake, I promise it will not be exactly the same as this one. So please pay attention to themes, ideas. Don't just try to memorize these answers because they won't always be the same questions or answers that you will see on a different version of the test. And we'll also kind of talk about some strategies that are helpful for all test taking. So let's start with number 1. Which of the following defines energy? This is a simple definition question. So this is something that you should have in your notes. But if you don't, let's kind of go through a strategy of process of elimination to help us arrive at the correct answer. So first one, the capacity to only store gravitational energy. This term only should set us off as an absolute that tells us it only does one thing. That's not good. Also, it's limiting it to gravitational energy, which is not going to be enough of a definition either. So we're going to say, nope, that does not seem likely. The capacity to make things brighter. Well, again, brighter is very limiting. Don't like the sound of that. That only would really deal with radiant energy. The substance that flows through computers, you notice I skipped C. Things that flow through computers, what are we talking about? Electricity here? Well, that's one kind of energy, but, again, too limiting. The ability to do work, that's nice and general. That defines a lot of different kinds of energy. That is the definition of energy. So we like letter C. Second question, energy cannot be created or destroyed. True or false? Well, this is the law of conservation of energy. Energy can be changed from one form to another, but you can't create nor destroy it. It flows in and out of systems. It flows between things and systems. But creating and destroying, we do not do with energy. So that is true. What kind of energy is stored energy? Well, remember, energy falls into one of two categories, either potential energy or kinetic energy. Kinetic energy is the energy of movement. Stored energy is potential energy. That is the definition of potential energy. Storage energy, that's a made-up term. Okay, know your vocabulary. Heat energy is a form of kinetic energy, and kinetic energy, we just said, is the opposite of stored energy. So we don't like that, and that leaves us with potential energy. All of the following are forms of kinetic energy except, potential and kinetic energy both come in several forms. And this is saying that most of these are going to be kinetic energy except one. Well, thermal energy is the movement of molecules. So movement is kinetic. So not this one. Motion. Well, we're just straight talking about mechanical motion here. No. Elastic energy. Well, that makes me think of springs and trampolines and rubber bands. Those things move. I'm just not sure about that one right now. What about sound energy? Well, sound energy is also the movement of molecules. So I have to revisit this elastic energy question. Elastic energy, imagine if you push a spring down. Now it has all of this capacity to push out and make movement. But when we've pushed it down, now we are storing energy. And that is what elastic energy means as potential energy. So elastic is a form of potential energy, not kinetic energy. When that spring releases, or the rubber band releases, or the trampoline pushes back on the little kid jumping on it, then it's going to be transferring stored energy into kinetic energy. But elastic energy is a form of potential energy. Food, fossil fuels, and batteries. All of these things are storing energy in the molecules of those things. Food is energy that we can eat, and when we eat, our bodies are going to break it down and turn it into some other kind of energy, often heat, but also our motion energy. Fossil fuels, same thing. When you combust or burn fossil fuels, it releases that energy, usually into thermal energy. Batteries are storing energy that once put into a circuit can then be used for electrical energy. So those are not kinetic energy. They are storing energy. And as we said before, stored energy is not kinetic, potential. It's also not nuclear energy. Nuclear energy is the energy that is within the nucleus of an atom. It is a very big event when an atom breaks down and releases that energy. That's a nuclear explosion or radioactive decay. Bad things. Radiant energy is energy given off as light. Food, fossil fuels, and batteries are not light energy. Chemical energy, yes, that is stored potential energy in the molecules of different substances. I like chemical energy. All right, we've got a couple of questions now coming up that deal with important equations from this unit. The first one asks, which statement best describes the relationship of mass and velocity to kinetic energy? Kinetic energy. So I need to know my kinetic energy equation, which is Ke equals 1/2 mass times velocity squared. If I've got that, now I can look at my options and make some pretty educated guesses as to what's going on. If I double the mass of an object, it has no effect on its kinetic energy. Well, here we have mass. If I double that, if that was 2 and now I make it 4, well, kinetic energy is also going to go up. So I cannot say that doubling the mass, no matter what numbers I use, will always have an effect. They are directly proportional. So this is not a good option. Option B, doubling the mass and velocity of an object have equal effect. Okay, if I double mass, let's say again I go from 2 to 4, well, if I take velocity and it was 2, which 2 squared is 4, and now I make it 4, 4 squared is 16. Wait a minute, that's not the same as happened over here with mass. Because of this squared is very important in this equation. What that tells me is that velocity is more important than mass. So they are not equal. Doubling the velocity has a greater effect on its kinetic energy than doubling its mass. D is telling me the opposite, that doubling the mass has a greater impact, and we can see that is simply not true. It is not squared. Any variable that is squared in an equation is going to have more importance on the thing being measured than a variable that is not squared. Okay, last question here is asking about gravitational potential energy. Well, that's a different equation. Potential energy is equal to mass times gravity times height, or distance above the Earth. Which factor affects potential energy? Mass? Yes. The pull of gravity? Yes. Distance from Earth? Yes. All three of them do. All of the above.